Alright, we're going to talk about S5F.1, Systems of Equations with Linear Models. Okay, first we're going to start off with a warm-up to find the missing angles. So I'm using the cosine rule, and a lot of you are used to seeing this and this. Now, which one am I going to use? We're trying to find the angles, right? So I'm going to be using this formula here. Now, a lot of students frequently come to me and say, hey, which one's the A, B, and C? Right? So when you look at this formula, don't worry about which one's A, B, and C. The thing you need to worry about is, or think about is, okay, so we've got this angle, whatever letter it is, right? In this case, it's a C. And so the ones that are going to be positive, that are squared, is the ones on either side of this yellow dot. And then the one that we're subtracting is the one that's furthest away. And then at my denominator, it's 2 times the one on either side here. So if you think of it in that light, here we are trying to find angle x. So I'm going to add the 26 squared and the 51 squared, and we're subtracting the 34 squared, which is the one opposite and far away. And then divided by 2 times 26 times 51. Those are the sides on either side of the angle that we're dealing with. And I think if you think of it this way, rather than with the A, B, and C, you're more likely to do this. So this simplifies to this, and then how do we find the angle? You have to hit second cos and to get our angle. Now, y here is going to be an obtuse angle, so it's best if you find angle Z first, and then once you have these two angles, you can add them together and subtract from 180, and then you can get angle Y. You may want to hit pause if you need to think about this some more. Okay, solving by graphing. So the first thing we did here is I know the y-intercept is -1, my slope is 1. I drew the red line here. And then the second equation, 2x, so I know my slope is 2 and my y-intercept is 0, and I drew this pink line here. I see that they intersect at -1, -2. Here, and we're solving by graphing. Okay, here the red line, my y-intercept is 3, my slope is 2, and I graph it like that. The blue line, my slope is -1, or -4, my y-intercept is 1, so down 4 over 1, right? And you look here and you think to yourself, what is that intersection? How do I figure that out? And when you're solving by graphing, it's kind of hard to figure out what the exact solution is. And I'm going to show the calculator steps on how I got this in just a minute. But before we go over the calculator steps, we're going to solve these by using elimination. And some of you may have forgotten how to do elimination. When you have elimination, you just add the columns together. 8x minus 5x gives me 3x. -y plus y, it's going to go away. 20 minus 8 is going to give me 12. And then I have x is 4, and I plug 4 into one of these equations. I just chose the top equation, so 8 times 4 minus y equals 20, and then I solve for y. Here's another example. I just add the columns together. 5x plus 2x gives me 7x. 3y minus 3y, it goes away, and 10 plus 4 is 14. Okay, once I've got 2, then I can plug a 2 into x. This is the equation that was right here, and then I solve for y and I get 0. Okay, so in the previous example on the first page, we were trying to find the intersection of these, and I'm going to show you how to use the calculator to do this. So so first we need to do a sketch. So my y-intercept is 3.5, and my slope is 2. So up 2 over 1, up 2 over 1. Here my y-intercept is 7, and my slope is 1/2. So I go up a half over 1, up a half over 1, and there's that line. And so how do I graph this using a calculator? So the first thing I do is I hit y equals, and I type in those equations. Okay, and I'm going to type in 2x, 2x plus 3.5, and the other one I'm going to type in 0.5x plus 7, and then I'm going to hit second trace. I'm going to go 5 or hit intersect, and okay, my window's kind of messed up. I'm going to hit zoom 6 to get a normal looking window, and then if I want to find the intersection, what was I do? I did second trace, 5 for intersect, and then it says first curve, I'm going to hit enter. It says second curve, I'm going to hit enter. And then it says guess. We are not going to guess, we're just going to hit enter, and now it tells me the intersection is 2.3 repeating, comma 8.16 repeating. Okay, and that's how you use the calculator to find the intersection. Okay, now if I want to get a table to plot points, you can hit second graph to give me a table so I can make a sketch. So I can hit second graph, and then I get a table which will help me plot some numbers. So 0, 3.5 is this dot right here. 1, 5.5 is this dot here. 2, 7.5 is this dot right here, the red one. And then 0, 7 is this blue dot. 1, 7.5 is this blue dot. 2, 8 is this blue dot. So you can use this table to help you plot points when you're making a graph. You might want to hit pause to copy these instructions. Next. Okay, the manager of the factory is trying to determine what to charge for an item that they've made. The demand for the item is using this function, where P is the price in dollars, and the supply of the item can be modeled in this function. Okay, so here we've got this function for the supply. And we have this function for the selling model. Okay. So sketch on the same axis. So we see that 800 is the highest point on the y-axis, and then my slope is negative. So I'm going to have the top of the graph be 800. Since there's 10 thick marks here, I'm going to have these each go up by 100. And then we figure out what this is going to be. So I decided to make it go over by 50s. So the first thing I did on here to make the sketch is I type in these equations. So 800 minus 2x, and then the other one is 3x, and then we oh, you can't see what I'm doing. Okay, and so then if I want to change the window, I have to press window. Oops. And I'm going to change the x max to 1,000. I could change it to 800 if I want. And then I'm going to change the y max to 850 here. And then I'm going to press graph, and then we'll see what our graph looks like here. Okay, and so I want to get some points to plot. So um, the easiest thing to do is I'm going to go by 50s. So if I do second window, I get my delta TBL, and I'm going to change this value here to 50, and so that when I hit second graph to get my table, it's going to go up by 50s. So the blue graph, 0, 0 is this point here, 50, 150 goes right there. 100, 300, so go 100, 300, it's right there. 150, 450 is right there, and so on. And then when I look over here, 0, 800 is right there. 50, 700 is right there. 100, 600 is right there. 150, 500 is right there. And so you can see how I'm using this table to help me get points for my graph. Okay. You may want to hit replay and listen to this again if you need help. Okay. Question C. Comment on the situation in which the selling price is 100. So when the selling price is 100, when the selling price is 100, you can tell that the demand is about twice as great. Okay, and then in contrast, what happens when the price is 250? So if it's at 250, you can see that the supply is greater than the demand. It's about 2.5 times greater. Okay, next question. Okay, some friends are planning to rent a car during the holiday. They have two options. Option A, it's $5 a kilometer, so that's going to be 5x. Option B, it's a fixed cost of 150 plus 230 a kilometer. So here's my fixed cost, and here's my 230 a kilometer. Okay. Here's our equations. So find the cost of renting a car if it travels 100 kilometers. So I'm going to plug in 100 in for x. I get 500, and 100 in for x in this other equation, and then I get 380. Question B, write down an expression for the cost for each equation. Well, I already did that. Okay, question C. They know the above a certain number of kilometers. Option A is more economical than option B. Find the value of k. So that's where they intersect. So I hit y equals on the calculator, put in the two equations. I'm going to change my window. I need to change the x max and the y max. And then if I hit second trace, enter, 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 that's going to give me my answer. Should we do it? Let's do it. Okay, 5x 150 plus 2.3x. Change the window. 500. 500. Okay. Second trace. I'm going to hit 5 for intersect. Then I hit, it says first curve, I hit enter. It says second curve, I hit enter. It says guess, I hit enter. And there's my intersection 55.56, comma 277.7. Okay. You might want to hit pause or rewind to see it again. Okay, question 4. Consider the function f of x equals this, g of x equals this, where m is a constant, and the graphs meet it here. Find the value of m. So to find the value of m, which is the slope for that graph, I'm going to plug in 5 in place of x and -9 in place of y, and then I can figure out the slope. And then question B, find the point of intersection of g with the x-axis. So it crosses the x-axis when y is 0, so I take this equation, I'm going to make y, or g of x, equal to 0, and then I solve for x. Okay, and so there's my function for, there's my intersection. Please watch this again if you have more questions.